All right. So yesterday, what we left off with was the 4-term grouping. So if we look at these two, a lot of you guys looked at them and thought of what number can divide into both of these.
6.
And we picked 6. Okay, so when we pick 6, that's awesome, makes me think of football. All right, if we pick 6 and then they both have an M in common, and we factor that out, we're left with 4M
Plus 7.
Because this is a minus, this needs to be a minus,
Okay,
minus 7. All right, so we want these two to match. So here we need a 4M and a minus 7. All right, so this is where it got tricky yesterday, right? Every time we had to look at the second part and go, what do I divide out of negative 20 so that it becomes positive 4?
5.
Okay, it needs to be 5. And because we want the signs to change, it needs to be negative 5. So, completely factored, this is 4M minus 7. So this part we always stick out in front. And then we group what's left. So this is left, and this is left. So that it gets grouped together. Who got it right? Woo! Alright, let's see. Does she have enough?
Enough piece of candy?
I'm checking. I got some. I think I have enough for the number of hands that went raised. Okay, who has it right that needs me?
At least we're on it.
I'd be balling out.
Anybody else? Woo! Oh! Yes, you did. I got one. There we go. All right. Okay, so let's go back and try one more of these. I want you to try number 14, and then we'll go back up to the top and try one of the easier ones too.
I'm not fairly good.
That's okay.
Oh, what's going on? Alright, so the number's going, this is 2.
Okay, so 2 is
2,
perfect.
2.
2 in square. Pull it out. You got it. Okay. And 1 is 5. Two goes into 10 how many times?
5.
Good. 5.
And 1.
5 and 1. Yeah.
So it's 4.
Yeah.
Then minus
Uh-huh.
3.
Awesome. Okay, so what do we want?
3.
We want the same thing over here, don't we?
Yes.
5 and 1. So I got it here.
5 and 1.
That's what you got right here. 5 and 1.
Well, there's another.
Wait for 1. Think about that. Now we got to think about it. I got 35. What do I divide out of 35? Get 5. 7. So plus 7. Okay. Take these two are the ones that are the same. It goes in front. 5 and minus 3. Those are the same. It goes in front. Okay. Now, when you take that out, what are you left with? 2 in the square plus 7. Group those together. Anybody need help?
Go ahead. I got it. That's all I got. Ready for it? No, that's all I have.
RJ, did you bring my flower back?
We'll be back by 7 period.
Wait, you just call him RJ?
I did call him RJ.
Why?
This is RJ.
Well, what are we going to do about it?
It could be RJ. Red Room.
What are we going to do? You're Jordan Jones. Jordan Harris, Jordan Reed. I'm good.
You have to say that though.
I will.
You just say Jordan.
I can't say just Jordan. You're right.
Jordan Reed.
And I also have two Bridgets, but Bridget and Elaine.
Jordan Reed with two E's.
Were you coming to for next?
Still in here?
I call you Jordan. I say underscore.
I need a schedule change. I want to get back on the weight room. No, man, I need to work out.
I busted tail and
Okay. So when we looked at the first two terms, what did you decide was the greatest common factor of the first two terms?
2.
2 and
Squared.
n squared. And when we factor that out, what were you left with? 5n minus 3. So over here we want 5n minus 3. So what do we factor out of this group? A positive 7. So the 5n minus 3 goes in front. And then we group what's left. 2n squared plus 7. And we have factored it. Okay, so those of you that were here yesterday and today, obviously you're here today, do you feel somewhat confident in this kind of factoring?
Yeah.
Okay, good. All right. Now let's revisit one of the ones at the top where we just had a GCF. Let's do number 8. So this isn't 4 terms, this is just 2. So all you can do is factor out the biggest number that divides into both of them. That's called the greatest common factor. And the variables that they have in common. Okay? I want you to try it, and I'll help you if you need help.
On what?
You didn't do it right yesterday, yeah. That's right. Uh-oh, did you not go to sleep on time?
What time are you going to say if they want to sleep later?
Monday is 3:24. I said this thing 2:30.
I wanted last night. I'm going to sleep at 4 in the morning. But I don't get tired, so you got to stay on the grind. Stay on the grind. At least 7? I prefer 3. I prefer 2 or 3.
I go to bed at 7:30 start every day.
He said he couldn't sleep at 7.
You gotta get to Cr Rev.
I can't go to sleep early. If I go to sleep early, I'm try the next day.
I'm alright with that. Just first period. Guess I'll play.
Oh, do you not have gym Thursday one? What do you have?
Physical science.
Do you not have any gym class?
I don't either anymore.
I had 2 and now I'm down to 1.
All right. I was seeing some good stuff as I was walking around. So if we look at this one, an 8 is a factor of both of these. 8 divides into 24 and 8 divides into 8. And then they both have an x in common and they're both cubed. And they both have a y in common. But we can only pull out a y to the first because this second term limits us. What do I multiply 8 by to get 24? 3. I need 3 x's. That's what I've got. So I don't need any more. Here I need 2 y's and I only have 1. So what do I need? 1 more. Now, the 8 matches, the x matches, and the y matches. But I need to hold its place, and it needs to be a -1 because that is negative.
I used 4. Is that like $9?
Okay, 4 works. But if the directions say completely factored, you always want to go with the very biggest number that'll divide in both of them. Okay. Today we're going to work on some other types of factoring. I don't know that we're going to get to all of our problems, and I may not even pass them out. Today we may just take notes. So if you could take yesterday's worksheet and just turn it over, we'll see how far we get. This is really important, and it's not really hard, but you're probably not going to remember it from last semester. So I want to make sure we learn it and learn it really well so that we can be very successful on everything we do. All right. Okay. Alright, so today we're going to factor trinomials that have a leading coefficient of 1. And that's math language for this. So this is going to be an understood 1.
Oh, whoa.
And then we can have numbers here and here. So these are notes, and you can start these notes on the top of the back page. Is it wet?
Yes. I'm sorry, it was not my fault.
I know.
Hey,
I would.
it's just a little mess. We'll clean it up. It's just water. It won't let it.
Well, it will if you touch it under there. Which was under desk.
Yeah, life proof. We're cool. Can we, do we write this?
Okay.
We write this? Do we write this?
Alright. Yes. These are our notes. So I'm going to start off with examples. Example 1. And I'm going to talk you through what we do as we do each example. So here's our trinomial. And the first thing we always look for is to see if any of the numbers have a common factor. And they don't. They don't all have an x. And there's not a number that divides into all of them. So I can't divide out a greatest common factor because it doesn't have one. When it's in this form, and there's the understood 1 out in front, the way you factor it is you ask yourself, what do you multiply to get this number that you add, ooh, I heard somebody say it, add to get that number. So you ask yourself, step 1, what do you multiply? Good.
So it's kind of like the box method.
Yes.
So it's 12 times 2?
To get the C part that you add to get the B part. Now, your teachers may have done it a couple different ways. You may have had to do something like this. Write down your factors of 10. What can I multiply to get 10? 1 times 10 gives me 10. And 2 times 5 gives me 10.
Hey, that adds up to 7, so like...
Okay? And so, then look at the sum. 1 plus 10 is 11.
No, that's not it.
2 plus 5 is
Hey, that's
7.
it.
It is it. Okay, now I actually didn't give them all to you because doesn't negative 1
Oh,
times negative 10 equal positive 10?
you're right.
And negative 2 times negative 5? Now, I actually didn't have to even think about those because we want two numbers that multiply to give us a positive. Yes,
That's
sir.
your minus 5.
It's 2 times negative 5.
Under the sum.
That should be plus. Sorry. Thank you. So we're multiplying to get a positive, and when we add them, we also get a positive. Well, the only way to multiply and get a positive and add and get a positive is if they're both positive to start with. So that's why we didn't even list those. So this is going to be what we're going with here, this choice. Because when I multiply 2 times 5, I get 10. And when I add 2 plus 5, I get 7. So this factors to x plus 2 times x plus 5.
You lost me here. No, I got you.
Okay, let me ask you, did any of your classes do it like this?
Yep.
What do I multiply to get 10 that I add to get 7? Did you do it like that?
That's what we're doing.
Miss
We
Woodward
did
did it both? Okay.
We did it.
So you may have done it this way, and so you had to just kind of play around with it until you got 2 and 5. All right, example 2.
Whoa.
Okay, x squared minus 9x plus 18. So we're going to do some thinking before we start. We're multiplying to get a positive 18. What can I multiply to get positive 18? And I'm adding to get negative 9. So I'm multiplying to get a positive, but I'm adding to get a negative. Don't they both have to be negative? Because a negative times a negative is a positive. So both of these numbers have to be negative now. Now if you wanted, you could list out the things that give you 18. 1 times 18, 2 times 9, 3 and 6, 4 doesn't go in there, 5 doesn't go in there, 6 is already stated, so I'm done. These are the only ways to multiply integers and get 18. So out of these choices, which ones can I multiply to get positive 18 that I can add to get negative 9?
I think it's 6.
I think it's 3.
It is. It is 3 and 6. But if I'm adding to get a negative, doesn't it actually have to be negative 3 and negative 6? So on these, when I just list the factors, we need to keep in mind they could be positive or negative. Positive or negative. So in this case, the negative is going to work out best for us. Because negative 3 times negative 6 is positive 18. And negative 3 plus negative 6 is negative 9. So this is going to factor to x minus 3 times x minus 6. What do we think? Are you ready for one to try? Okay, we're going to try one. The first one we're going to try, I'll give you a hint. They're both going to be positive, okay? So here it is. X squared plus 10x plus 16. Because it's positive and positive, we know we're looking for those positive factors. Okay, if you're not sure what to do, you ask for help. Saw some good stuff when I was walking around. Okay, so when we think about this one, we're thinking about all the things that can multiply to give us 16 that we can add to get 10. And I saw you writing out your factors. What are the factors of 16? Now we need to, these are positive and negative, but 1 and 16,
8 and 2,
8 and 2, and 4 and 4. Okay, and the one that works for us is 2 and 8. Because 2 times 8 is 16, and 2 plus 8 is 10. So this factors to x plus 2 times x plus 8. Let's try one more, and then we're going to do ones where the signs have to be different. X squared minus 13x plus 36. X squared minus 13x plus 36. So when we're going through our thought process, we're going, I'm multiplying to get a positive, but I'm adding to get a negative. What does that tell me about the signs of those numbers when I'm multiplying to get a positive, but I'm adding to get a negative? Who can tell me?
Both negative.
They're both negative. You're right. They're both negative this time. So when we start thinking, remember they're both negative. Let me know if you need help. 36 has more factors, doesn't it?
One thing out here.
This is your thing.
Because they're multiplying to a positive, they both have to be negative. So it's x minus 9 or x minus 4. Then you got So we're multiplying to get that positive 36, and we're adding to get the negative 13. So when we think about our factors, when I was walking around, I saw some good factor lists. 1 and 36, 2 and 18, 3 and 12, 4 and 9. We can stop there because that's our winner. And the other would be 6 and 6. So this is going to be negative 4 and negative 9. We're multiplying to get a positive, yet we're adding to get a negative. So it gives me x minus 4 and x minus 9. Now, if we wanted to check our work, it would be really easy to do. We would just have to distribute through.
I'm like looking at it going, this is nothing.
Look at this. Will this still be right? I don't know.
Ooh, I like your question. It is right. Ooh. Okay? If you wrote x minus 9 and x minus 4, that is also correct. And the reason why is because multiplication is commutative. We can switch the order. Like 2 times 5, isn't that the same as 5 times 2?
Yeah.
Yeah. So x minus 4 times x minus 9 is equivalent to x minus 9 times x minus 4. The order of the parentheses doesn't matter. Okay? The order of the binomials doesn't matter. Now, one way to check, either way you did it, one way to check to see if you did it right is to distribute back through. Do you guys remember doing this? Where you took this term and multiplied it through? X times x is x squared. X times negative 4 is negative 4x. And then took the second one and did the exact same thing. If we take this second term and multiply through, negative 9 times x is negative 9x. Negative 9 times negative 4 is positive 36. And when we combine our like terms, did we get what we started with? Yes. So if you have time, if you're working on a test for something and you want to check your work, this is a great way to check your work, to multiply and back through. Okay, now we're going to look at some that have different signs. So what do we do when our factors are different? So this would be example 5. Okay. And we know they're different, and the reason we know they're different is we're multiplying to get a negative 20. The only way to multiply and get a negative is if they're different signs to start with. A negative times a positive, or a positive times a negative. We know they have to be different signs. So we're multiplying to get a negative 20, and we're adding to get a positive 8. So what can I multiply to get 20? What are my factors of 20? 1 and 20, 2 and 10, 3 doesn't go in there, 4 goes into 20, 5 times, and 5 is already listed, so I'm done. So these are my possibilities. And we know they have to have different signs because I want to get a negative 20. Will any of these combinations work if I did different signs to add up to give me positive 8? Yes. Which group are we going with? 2 and 10. Now, we know they have to be different signs, and we want our outcome to be positive 8. So the bigger number needs to be positive, right? Positive 10 and negative 2. Negative 2, positive 10. So this is going to factor to x minus 2 times x plus 10. All right. I'm going to give you one to try that is similar. Okay, so you try number 6. So we're multiplying to get a negative 18, but we're adding to get a positive 3. So we know they have to be opposite signs. All right. All right. So we look at our list. The factors of 18 are 1 and 18, 2 and 9, 3 and 6. And that's it. That's all that'll go in there. So we're going to go with this one because if we subtract these two, we get a 3. So we know if these are opposite signs, it works for us. So to multiply to get a negative 18, whoop, that didn't look like an 18. Try again. And to add to get a positive 3, we're going to go with a positive 6 and a negative 3. So you could have written your answer as x plus 6 times x minus 3. Or you could have written your answer as x minus 3 times x plus 6. It doesn't matter which binomial comes first. Okay, let's look at the last possibility when we have different signs. We could have this. This is number 7. A negative middle term with a negative constant.
Oh.
Okay, so this time we want to multiply them and get a negative, so we know they're going to be opposite signs, and we want to add to get a negative. So we think about 28, 1 and 28, 2 and 14, 3, no, 4 and 7,
That's your answer right there.
and that is my answer right there. Because when I find the difference in these two, because I know they have to be opposite sides, I can make that be -3. If I have a +4 and a -7. So we take those factors, the 4 and 7, and make that larger one negative, so that when we add it, we get the negative. So this factors to x plus 4 times x minus 7.
That's the last problem for today?
This is the last problem.
Gosh, tricked me there.
I did. Okay, I'm going to give one for you to try, and then we are done. One and done. So we want to multiply to get a negative and add to get a negative. I'm going to give you one similar. Multiply to get a negative, add to get a negative.
Got it already.
I am so excited that this is easy.
I'm sure it out though.
You do. You do. Okay, help me check. Help me check that.
I can get some water. Can I get some water?
That's it.
Can I get
Yes.
some water?
Yes, you point out your answer to me when I get to you. That's it. Yes? Okay, wait. Yes. Yes. Which one? This one. You got it. Yes. That's it. That's it. That's it. That's it. That's it.
Hey, Miss Goodrich.
All right. So if we think about the factors of 14, we have 1 and 14. We have 2 and 7. And that's it, isn't it?
Yes.
So which one of these, if I subtract them, I can get 5? The 2 and the 7. But we need the 7 to be negative so that we can get a -5. So what can I multiply to get -14 and add to get -5? +2 and -7. So these are our two binomials. X plus 7 times x plus 2 times x minus 7. Now once again, the order of the binomials doesn't matter because it's multiplication, and multiplication is community. All right, how do you feel about this kind of factoring? Better?
Love it.
All right, love it.
Love it.